All right, now we want to explore MATLAB a little bit and see what we can do with MATLAB. Some of the first kind of basic concepts, such as like, how do we input a matrix? How could we get this to spit out the sum of two matrices or the product of two matrices, et cetera, et cetera. Okay. And so when you open MATLAB, you see it comes up to just a blank command window here. No files created, just kind of a blank command window here. And let's start by defining a matrix. And so to define a matrix, we'll call it A. You define variables in MATLAB simply with the equal sign. So when I say A equals here, the software is reading now that I am going to define this variable A as whatever I write as follows. And now to describe a matrix in MATLAB, we start with a square bracket that opens this, this command. And then we simply type in numbers, and we split numbers via commas or spaces. And I'll give an example of both. So let's say we want the 3x3 matrix 1, 2, 3 in the first row, 4, 5, 6 in the second row, and 7, 8, 9 in the third row. And so we would type this 1, 2, 3, and we split each entry by a comma here. And that's for the first row. Now to indicate that we're going to the next row, we'll type a semicolon. And so now MATLAB says, all right, this is the second row of entries. And I could go 4, 5, 6, and we'll hit a semicolon, which will go to the third row. And then we can go 7, 8, 9. And now to close or to finish describing the matrix, we close with the opposite square bracket here. And now if you simply hit return, the command window spits out what you've defined to be a 3x3 matrix, right? It's now saying, okay, what you just told me was that A will from henceforth be a 3x3 matrix given by the entries 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to show that you don't have to use commas to split the numbers, but you still need to use semicolons to split the rows. So let's say we wanted to do the following 3x3, 9, 8, 7 for the first row. And notice how I'm no longer using commas here. Now I'm splitting by a space. This also acts to distinguish between entries in a given row. And then so I could go 6, 5, 4, third row, 3, 2, 1 via a space. And then I hit enter. And now the command window lets me know that what you've defined is the 3x3 matrix B given by 9, 8, 7, 6, 5, 4, 3, 2, 1. Great. So now this command window is keeping track of A and B as their own variables. And if you ever can't remember, if you go to the right over here, you see this workspace, it keeps track of your variables and values for you. Here's the variable that you defined. Here's what it's assigned as with the value there. Another thing we can do in the command window is, let's say we want to define let's make something a little different here. Let's do, I'm just going to pick some numbers here. Let's say 9, 5, 4, 3, or 9, 5, 3, 4 rather, and then 2, 0, 0, 1. Let's say we have the following 2x4 matrix here, or 4x2, excuse me. And let's say I don't want this. So you can see up here, when I type A, when I define A, when I define B, the command window lets me know what I defined afterwards, right? Let's say you don't want that to be the case. Well, if after you define a variable, if you include a semicolon and hit return, the command window will process the definition you just assigned to this variable, and it will even record it for you over here. See, it says C is equal to this matrix 9, 5, 3, 4 in the first row, and then in the second row 2, 0, 0, 1, right? But the semicolon acts as kind of silencing it in the command window. So if you need to define a bunch of matrices, but you don't want them showing up all the time, you add a semicolon here. and it will record the variable for you, but you don't necessarily have the command window kind of repeat what you just defined. Now, one thing we can do is let's look at augmenting a matrix. Let's start a new matrix D, and let's say D is going to be A augmented B. And what this is doing here, this notation, is it's taking the matrix A in the first as the first piece of the matrix D, and then the semicolon here, when it's representing, when a semicolon is splitting two matrices, it represents augmentation, right? When a semicolon is representing or splitting two numbers, it's simply a break in the row, right? And you go to the next row. But when it's a semicolon splitting two matrices, this serves to augment our matrix as such here. So, and we get, it tells us what it is. It's a 6x3 double there. Okay. Now, if you'll notice, what we're doing is at each step here, we can start to try and think of different operations. Well, what if we wanted A plus B? Say we want to calculate the sum A plus B here. I can tell just by inspection that it should be a 3x3 matrix where every entry is a 10, right? Because you would have like 9 plus 1, and then 2 plus 8, and then 3 plus 7. And so in MATLAB, if you just type A plus B and hit return, it will tell you what the answer should be. And here we get a matrix of all 10s. So let's say we wanted to do subtraction, right? Because if you can add matrices, you can subtract matrices. So if we do A minus B, we get the following result. And we can even scale these. So let's say for multiplication, for scalar multiplication, let's say we wanted to take A and double it. And now for scalar and matrix multiplication, you always have to use the asterisk or the star there, right? And I will show an example. Let's say I just type 2A and hit enter. It doesn't know what I want. And it'll suggest, it's smart enough to recognize that, oh, he probably wanted scalar multiplication. And so you can see scalar multiplication will not compile if you don't input it with an asterisk here. And the same is true of matrix multiplication. Let's say we want to take the product of A and B. Well, that would be listed as a variable, right? And this is saying that I have an undefined variable. Now, if I wanted, I could say AB is defined as A times B, right? And now for matrix multiplication, I'm using this asterisk again to indicate that I want to multiply these matrices together. And so if I hit AB and define it to be A times B, well, now I get AB as the product here. I could also do like BA equals B times A, right? And I would get something similar. Here's a good example of why matrix multiplication is not commutative in general. All right, some other things we can do are we can start to compile files together, right? Because like, what have we done here? Notice in the command window, I can only define or type one command at a time, right? I type A, and then normally, like if you open a script, say if you're in like C++ or Python or something, when you open a script, you type a command, you hit enter, it goes to the next line, right? It doesn't try to compile this every single time you want a different command. Well, in MATLAB here, what we've seen in the command windows, I can only type one command at a time. And that gets extremely tedious. And you can see just by these basic defining a variable, computing their sum, et cetera, it gets a little old. One thing you can do is to keep all of your variables here on the right. You want to keep all these variables, but you want to get rid of all this stuff that the command window spit out. What you do is you hit CLC. You type CLC and hit enter. That stands for clear command window. And so now notice all my variables are still stored, but now I can start typing again if I wanted. But again, with the command window, it's only going to be one line at a time. And now let's say I want to completely start over. Let's say I don't want these variables here anymore. Say I want a new matrix A that's defined differently. Well, you type clear space all. Clear all clears all variables, okay? And then notice there's something in the command window again. So if I hit CLC, then I clear the command window and I'm back to nothing basically. Now, if I want a file that I can type more than one command at a time and something that I can save, I'm going to come up here to the top left of the application. And I'm going to open a new script. And you'll see here, I now have the command window still down here, but now I have this editor. And this is where you'll type up your labs, right? So here is where, and to make a comment in the script file, you'll always use a percentage sign and say, here would be where you create and save a lab assignment, right? This was a new script. And here, now we can type line by line. Let's say I wanted to define this matrix A again. Right? Now I've defined the matrix A to be 1, 2, 3, 4, 5, 6, 7, 8, 9, et cetera, et cetera. And I wanted B, right? Now I can define B again. Let me define it to be something else this time, something less trivial, like 2, 6, -1, 0, 8, 12. And then we'll still have it 3 by 3, I guess. So how about -2, 0. Oh, I used a space, which is fine, right? You can do either, but to stay consistent here, I will stick with commas. Do whichever one is more comfortable for you. Okay, and now I can define all of these things at the same time. And the semicolon trick at the end of a line or at the end of a definition still works to not display those variables in the command window once you hit run, right? So we'll type out our script, and then we can hit run here, and it will kind of process all of this stuff at the same time. So let's see, I've defined these 3 by 3 matrices A and B, but I don't want those to show up. I know what they're defined as. That's not like a calculation that I need to see the result of or something, right? And then we can define variables, and I'll want these variables to be something like a computation where I can see the result. So let's say I want the sum. We'll define a variable to be sum AB as A plus B, right? And if I do this and click run, it's going to want me to save it as something, right? And let's call it lab 1 practice. And I hit save, and now it's saved as an M file. And when I hit run, it spits out the results from this script, right? From this M file. And so here the sum of A, B was 382, 413, 18, 599. Great. And you can notice A and B did not show up in the command window because I asked them not to with this semicolon. There's no semicolon here after the sum of A and B. And so for that reason, I get just what I want here. And now you can continue to write and update your file and then run periodically to check and make sure you have no errors. So what if I wanted the difference of A and B? Well, I'll define this to be A minus B. And we've seen now what the sum of A and B is. So let's just run this for the difference, right? You can still access the sum from the first time it ran. And so I don't need that showing up every single time I run this lab, right? I just want the new results now because I have access to the old results. And so now we just have the difference of A and B. We can do, let's define like scalar multiplication of A to be like 0.4. Remember, you have to use an asterisk for times. And then let's say we also want to do like matrix multiplication. of A and B, or I could simply name it AB if you would like. And we can define this to be A times B here. And now I've seen the sum and the difference, so I'll add a semicolon there, but I haven't seen the scalar multiplication or the matrix multiplication here. I come up and hit run, and I get the result. I get the result of A scaled by 0.4, right? And then I get the result of A times B. And you can still see over in the workspace here, I have all of my variables defined and their values. And remember, I can always do CLC to clear the command window. So I want to keep everything that I've defined in this script here. And I want to make sure that I still can keep track of my variables and their values, but the command window is getting really long. Like, you know, I've run this a lot and there's a lot of things going on. You can always hit CLC, enter to get back to a clean blank command window. Another thing you can do in the editor here is you can just run sections. So if you add where you're writing a comment, if you start with 2 percent signs, this starts a new section. So here, let's start over here. Let me get rid of this description, right? And so you can see if I have nothing, then all I have are these defined variables. If I enter a percent sign, then I'm starting a comment. If I enter another one, this yellow here indicates that I've started a new section. And so this line still acts as a comment. So here, as like a note to yourself, you could say like section 1, definition of variables. So say in the first section here, I am just defining my variables. Well, then I could go and create a new section here, right? You can see now how I've split this this script into sections, and this could be sum and difference section, right? And then maybe I want a third section even of scalar matrix multiplication, right? And if we got rid of everything, or if we got rid of all these semicolons here, then you can see I have this split into 3 sections based on these double percentages. And what I can do is if I'm a little worried about how just one section is going to run, what you can come up here and click is run section. And so if I run just section 1, the section that I've selected, right, it lets me know I'm selecting that section based on the highlight there, then it will just run and spit out whatever commands that the script reads in that section. And so you can always check kind of section by section. So let's say I don't want to run, like say I know there are some issues with section 2 here, the sum and difference. I ran section 1, that's great. For section 3, I don't know if there's a problem or not. Let's run just that section, right? And so now I can see what scalar multiplication of A and the product of A is, and A and B are here, without having to run this middle section. Obviously, this is a little silly for a script so small, but once the labs in the future, once we start getting bigger and bigger script files here, it may make more sense to section these off. And sometimes the instructions in the lab assignment will ask you to make a new section, right? And the lab assignments will have you answer questions. And so you'll always answer a question like Q1 here, like you make a comment with one parenthesis, with one percent sign. And then the lab will have you, you type your code and then you answer a question. And so maybe the question is, what are the size of A and B, right? If the lab assignment were to ask you here, what are the size of the matrices A and B that you've defined? Well, then in the comment, you would type the size of A and B is 3 by 3, right? This is like an example. Or for example, the lab would ask you to type a second question. And maybe the second question is asking you, what is the variable sum AB representing, right? And then you would say sum AB denotes the matrix addition of A and B, right? Like this is an example of how you will answer lab questions in the comments, right? So you'll have like all of these variables and this code that you're required to type up based on the lab instructions, but you'll also have to answer questions too. And this is how I'll ask you to format it here is you'll say what question you're answering and then with your answer. And really here, I'm not looking for paragraphs. If you could keep it to a line, even that would be optimal. If your answer has to go into a second line, then that's okay. But we're not looking for short stories here. Just a simple statement that answers the question. And for example, if I was asking, what are the size of the matrices A and B? That would be my favorite answer right there, right? Because it's short, it's correct, and it's all in one line. And for example, here you could shorten this one by saying, well, that just denotes like sum AB denotes matrix addition of A and B, et cetera, et cetera. Okay, and so now once you hit run and you are finished with your script, you can see it's saved over here on the left. Like here I have this lab practice 1 M file. This file, this .m file, is what you will submit on Canvas. So once you've finished your lab and you think your script is correct, your variables are named identically to the variables listed in the lab assignment. Once you think everything is as good as possible, you'll run your script one last time to make sure that everything's okay. And then the M file here is what you'll turn in. And you'll just submit this. It will just be a file submission on Canvas, right? Like I will create an assignment on Canvas that says like lab assignment 1, and then you'll click on that assignment, and then you'll be prompted to upload a .m file. And so that's how you will submit a lab. Okay, so I think I'm going to stop here for the introduction to MATLAB. What I'm going to do is I'm going to upload the lab 1 assignment. And now I have not discussed all commands that are discussed in the first lab, but the purpose of the lab here is kind of to take what you know and what I've shown here and see what other kinds of commands we can talk about. The lab will walk you through pretty carefully what code to type, what commands are, how they're defined, right? So the first lab will kind of build on some of these things, right? So it'll look at like the sum and difference of matrices, scalar and matrix multiplication. Well, it'll also explore some different commands, such as creating a matrix with random entries. Like say you want a 5x5 matrix that each entry is randomly generated. Or let's say for a given row, you want to be able to find the maximum entry in that row. That would make sense when you're trying to optimize something, right? You want to just kind of type in just type in a command that optimizes like the entry in that row for you or things like that. So those are what's going to be explored in the first lab here. And hopefully this was a sufficient introduction to some of the basics of MATLAB, like what's the command window? We can type things and view our outputs in the command window. We have the workspace that's keeping track of our variables. How do we open a script? How do we save a script? And some of the basic language of MATLAB. And so after watching this video, you should be well equipped to starting lab 1. And so lab 1 will be posted. if it's not posted by the time you finish this video, it will be posted very shortly thereafter. And as always, I'm happy to answer emails or have students show up to office hours if you're having issues with accessing MATLAB or issues with MATLAB itself once you have access to it. And so tomorrow, what we'll do is finish up our lectures for the first week of class. We'll talk about some different operations on matrices, such as like a matrix transpose, computing the multiplicative inverse of a matrix, and things like this. So this is where we'll go from here.